today we're going to be talking about the nuclear physics. In the nuclear physics, we're going to be talking about a lot of things, especially alpha decay and beta decay. Let's consider the beta decay. The neutron emits the electron. Now, what? Now you're probably thinking, the neutron has zero charge. How can it emit electron to leave the nucleus? That's exactly what happened. One of the neutron emits the electron to leave the nucleus so that the atom can become more stable, and become a happy atom. For example, carbon 14. Carbon 14 is not happy because it's isotope. It has only 6 proton, but it has 8 neutron. So it wants to become stable. So is one of the neutron wants to what? Wants to emit. One of the neutron wants to emit the electron. So if it emits the electron, it loses one of the neutron, and it gains one of the proton. So the carbon 14 become the nitrogen. So the carbon 14, the unhappy atom, become the nitrogen, the happy atom. This is what we're going to be talking about. Are you excited? We'll start our conversation with 4 fundamental forces. Number 1, gravity. It was discovered by Sir Isaac Newton 1665, and the gravity allows the two bodies to pull each other. It's an attractive force. So gravity is an attractive force. I'm going to give you 2 examples. So there is an attractive force between, for example, the electron and proton in a hydrogen atom. So this is a hydrogen atom, of course hydrogen 1, and there is an attractive force between proton and electron in the hydrogen atom. And how much is that? 4 times 10 raised to negative 47 Newton, almost 0. How much gravitational force between electron and proton in a hydrogen atom? Almost 0 Newton. Now let's go big. Now we're going to get to see the gravitational force between moon and the earth. How much gravitational force the earth apply on the moon to pull it to the center of the earth. So this is the earth. This is the earth, and this is the moon. The gravitational force between the earth and moon is 2 times 10 raised to 20 Newton. It's a strong gravitational force the earth has on the moon. Okay, now let's check the next fundamental force. Electromagnetic force was discovered by Charles Coulomb. (1785). And electromagnetic force, the equation for electromagnetic force is electrostatic force, for that matter, is similar to the equation for universal gravitational force. So F E is equal to K Q over R square, and the force between the electron and proton in a hydrogen atom is quite big. This is the hydrogen atom, and electrostatic force between the electron and proton. So the proton pull the electron in the hydrogen atom, quite big. If you compare the gravitational force between the electron and proton in a hydrogen atom and electrostatic force between the electron and proton in a hydrogen atom, you see that the electrostatic force between electron and proton is 39 times bigger. Now let's see the electrostatic force between the moon and the Earth is 0. Not joking, it's 0. This is the Earth, this is the moon, and electrostatic force between the Earth and the moon, electrostatic force between gravitational force between the Earth and the moon is 2 times 10 raised to 20 Newton, but electrostatic force between Earth and moon is 0 for that matter. Why it is 0? Because Earth 0 Newton. Never forget your SI unit. Why it is 0? Because of course the Earth is in general neutrally charged and moon is in general neutrally charged. So what would be the electric force between two neutrally charged objects? And that is what you get. Okay, now you're gonna get to see the strong nuclear force, of course. Strong nuclear force was discovered recently between World War I and World War II, and it was discovered by a Japanese physicist. It was discovered in 1935 by Japanese physicist So what is the job of, you already understand the job of the gravitational force. Newton help us understand the gravitational force, and you also understand the electrostatic force. Now we're going to get to understand the strong nuclear force. What can strong nuclear force do? Well, consider atom. There are many types of atoms. If you look at the periodic table, you're going to see 118 different type of atoms. We're going to be probably just pulling some of the atoms from the periodic table, not so big one. If I write the californium, for example, I would be kind of drawing protons like next half an hour because it's just too many protons. So I'm going to choose not too big one. Okay, so let's choose, I don't know, maybe nitrogen. So nitrogen. So let's write nitrogen. Before I do nitrogen, I'm going to write X that represents the atom, A that represents the atomic number, and of course N represents the atomic mass. So let's write it down. X is atom, A is atomic number. Atomic number is number of proton, of course, and N is of course the atomic mass. Atomic mass is a proton plus a neutron. So then how do I know how many neutrons in an atom? Okay, so neutron would be equal to N minus A. So let's consider an atom. I don't know nitrogen, so X would be nitrogen. Okay, so atom and nitrogen. Nitrogen has how many proton? Proton is something that define the atom. Okay, so hydrogen, helium, lithium, beryllium, boron, carbon, and nitrogen. Seven proton. And what is the atomic mass? That means number of proton and neutron. Of course, 7 plus 7, 14. So how many atom? What is the atomic number? 7. What is the atomic mass? 7 plus 7. So the neutron, how many neutron? Atomic mass 14 minus atomic number 7. So 7. So how many neutron? 7. All right. This is how we're gonna be understanding the atomic number, atomic mass, and calculating number of proton in the atom. Now let's draw the Bohr model for nitrogen atom. So these are the protons in the nitrogen atom. So let's draw the neutron. This is the neutron in the nitrogen atom, of course. This is the nitrogen atom. We can write it N, 7, and 14. This is the nitrogen atom. Now, something wrong. You should be disturbed by this nitrogen atom. you should be asking yourself questions, because this nitrogen atom, as you see, should not be stable, and you should feel bothered. You should be asking yourself million questions, because this nitrogen atom, the way I draw it, is it should not be stable. If the nucleus of nitrogen atom is unstable, then atom is unstable, and since you made of atom, you should be unstable. Then if I made of atom, and I of course am a bag of atom, I should not be stable. Now here I am talking to you on the phone, so I think I'm stable because I am talking to you, recording this video explaining the very fundamental things of the universe. So why this nucleus is stable? First, let me see why I said that it should be unstable. It should be unstable because, as you see, that electrostatic force, there should be a repulsive force between these two subatomic particles, between these two charges. There should be a repulsive force between these two charges. Why is that? Because this is like charge and this is like charge. There should be a repulsive force between two like charges. Now there are 7, not only 2, there are 7. There are 7 like charges sitting inside the nucleus of the nitrogen atom, and still it is stable. Why is that? We should be bothered by that. Why it is still stable, although there are 7 like charges sitting inside the nitrogen atom? And that is the case for every other atom except hydrogen. This is the case for every other atom except hydrogen, be it helium, lithium, barium, boron, carbon, nitrogen, oxygen, sodium, aluminum, any atom that you talking about should be unstable, because like charges repel. Now, one thing that is responsible for make it stable, or at least hold it together, and that is a strong force, because a strong force is stronger than electrostatic force within 10 raised to negative 15 meter from the center of the nucleus. So if this is the center of the nucleus, 10 raised to negative 15 meter, 10 raised to negative 15 meter, within that area, within this the location, the strong nuclear force is stronger than what? Electrostatic force. This is why this strong nuclear force hold the proton together. This is why the nucleus is stable. This is why the atom is stable. This is why I am is stable, and this is why you are stable for that matter. But then why you need weak nuclear force? Okay, strong nuclear force hold the proton together inside the nucleus of atom, be it helium or be it nitrogen or be it anything for that matter. No. For 2 reasons you need the weak nuclear force, and that's what we're going to be talking about today. Weak nuclear force. Weak nuclear force was discovered by Abdus Salam from Pakistan, Weinberg and Glasgow. It was discovered pretty recently, 4 years after I was born. I was born 1979. I still I don't remember, but it was after I was born. I think I remember the big thing happened. I listened to the radio. I still remember, done by a South Asian physicist named Abdus Salam, along with 2 other scientists, Weinberg and Glasgow, discovered the weak nuclear force. Finally explained the biggest puzzle the biggest puzzle, what causes the decay and why there has to be decay, why there has to be a nuclear decay. All right, two reason there the atoms goes through the decay, nuclear decay. Number one, when you are an atom and your nucleus is too fat. What am I talking about when I say you are an atom and your nucleus is too fat? Anything that is beyond bismuth, anything beyond bismuth, consider as just too fat. What happened with bismuth? If you are a bismuth, then your nucleus, how many proton? Can you imagine? I am now 70 kilogram. I am now 70 kilogram. All of a sudden, if I become 700 kilogram, what happened? Then the door at my house has to be bigger for me. Then I won't be stable anymore. If I become all of a sudden, if 70 kilogram Mr. Berry becomes 700 kilogram Mr. Berry, then there would be a problem. Mr. Berry won't be stable anymore. Same thing for atom. If atom nucleus become too big, just like bismuth or polonium for that matter, or californium or einsteinium and so on, then its nucleus is just too big. It cannot be stable. So the weak nuclear force allow this nucleus to become stable. How? By nuclear decay. By nuclear decay, it loses some protons. And it becomes smaller in size, so that a strong nuclear force can defeat the electrostatic force and hold those protons together. Follow my argument? Tricky business, but if you follow my argument, you should be able to understand it. Not a rocket science. Okay, so weak nuclear force. For example, I'm going to give you two types of, for example, hydrogen. So we talked about earlier, we talked about the hydrogen atom. We're going to talk about hydrogen atom, but different type of hydrogen atom. The type of hydrogen atom that allow us to make the hydrogen bomb, the nuclear bomb. Okay, so we're going to talk about the hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen 1, of course, the hydrogen we know, the hydrogen that bond with oxygen and makes water molecule, and we drink and no problem. I just drank water and no problem. So the typical hydrogen with just one proton inside, and deuterium so deuterium also, if deuterium make a bond with with oxygen and make water molecule and you drink it, no problem, you're not going to die, promise, you're not going to die. So what's wrong with deuterium? You have one neutron and one electron, but tritium you have one proton, two neutron and one electron, and this is highly radioactive. Is tritium bound with oxygen and makes water molecule, and you drink it, you will die almost immediately. Why? Because this water would be radioactive, because this hydrogen is radioactive. So this guy badly wants to become stable, because this is not stable. This guy badly wants to be stable, badly wants to become stable. Okay, so one reason you want to become stable, when you are isotope. This is isotope. Why? Because number of neutron is not equal to number of proton. You have more neutron inside your nucleus than the proton. This is number one reason you want to decay, nuclear decay. And number two reason, when your nucleus become too fat. For example, if you are polonium, okay, if you are polonium, how many proton you have? 83. So you want to lose some of the polonium, you want to lose some of the proton. So you want to what? you want to become stable. And talk about two types of decay, alpha decay and beta decay. All right, so let's first talk about alpha decay. So consider an element. An element has some proton. These are the proton, of course, positive. And these are the neutron. And let's say 4 of them, so this is also a proton. So these 2 are proton, these 2 are neutron. These 4 of them all of a sudden realize that they no longer fit in with the nucleus of this element E. Element made of proton and atomic mass, atomic number and atomic mass. So this proton and neutron, they think they no longer fit in within this environment, so they emit. They get emitted, and which we call alpha decay. And when they emit, when they go through alpha decay, what happens? They lose 2 proton. They lose 2 proton, and they also lose 4 atomic mass. So P plus N minus 4. All right, so let's give you an example of, I don't know, anything that after Bismuth. Let's say polonium. Why polonium? Polonium is suffering, Poland is suffering much nowadays is because what happened with Ukraine due to Russian invasion. And polonium is named after Poland because Marie Curie, who was born in Poland, discovered the element polonium, and she named after her native country, Poland. Okay, so now let's say polonium. Polonium has 84 proton. And what is the atomic mass? 210. Why this guy want to go through nuclear decay? Its nuclear is just too fat. So 2 of the neutron and 2 of the proton decided that they just want to leave the polonium nucleus so that the polonium can become stable, so that the strong nuclear force would be enough to hold the nucleus together, because it's understand that strong nuclear force only work 10 raised to negative 15. Okay, good. So then what happened if it goes through the alpha decay? Another name is the helium decay. Why? Because in helium is 2 proton, and helium nucleus is 2 proton and 4 atomic mass. This is alpha decay is equivalent to helium nucleus. All right, so then that's what we're going to write, 2 and 4. So now 84 minus 2 would be 86, 82, and 210 minus 4 is 206. Now 82, what do you want now? You want no longer a polonium because you lost 2 proton. Now you are totally a different element. Now you are lead. More stable. Why? Your nucleus is small, now become small in size, so that the strong nuclear force can be able to hold you together. All right. Now let's talk about the beta decay. Let's consider some of the proton. All right, now let's put some proton, neutron. All right, now neutron has no charge, but one of the neutron in the element E, which is a proton and neutron, decide to emit electron. And now you are thinking about, hey, what are you talking about? Neutron has no charge. How can neutron emit electron? That's crazy. Yes, crazy things often happen, especially inside the atom, especially inside the nucleus. when you learn the quantum chemistry, you'll know more about it. Yes, this guy emit electron. The neutron emit electron. Now you're thinking neutron, it has a zero charge. How it emit electron? Yes, it emit electron. Electron has a negative charge and zero mass. Why? Because 9.11 times 10 raised to negative 31 is almost zero. So it has a zero mass. Okay. So if that happen, so it loses what happened? It loses the neutron become proton. So it gains actually one proton by losing neutron. So yeah. So then let me give you an example. Carbon, let's say carbon 14. Carbon 14 is not happy. Why carbon 14 is not happy? Carbon 14, the number of neutron is too much. There are 6 electron in carbon. There are 6 proton in carbon, and there are 8 neutron in carbon. So how many proton? 6. How many neutron? 8. 14. So 6 is definitely not 8. So carbon 14 wants to also go through decay, so become stable. And particularly this one want to go to alpha decay, because its neutron want to emit an electron so that it can lose some neutron, and then it can gain more proton, so it becomes stable. Crazy thing happen. So go learn some quantum chemistry, and then you'll be excited. All right, let's see how that happens. The beta decay, you can write beta decay is like this. So -1 and 0. So what number -1 is 6? You guessed it right. And what number -0 is 14? You guessed it right. Now what element has a proton of 7? You guessed it right. Nitrogen. So carbon 14 become nitrogen. And is this happy? Yes, this is super happy, because guess what? Number of proton is equal to number of neutron. This is happy. Okay, because number of proton is equal to number of neutrons. 7 plus 7 is equal to 14. All right, now finally we're going to be talking about the matter for next few minutes, and then we're going to end our conversation. Okay. And a matter, what do we get? We get hadrons and leptons. And we break hadrons, what do we get? We get baryons and mesons. When we break baryons, what do we get? We get 3 quark, and we get quark and anti-quark. Okay, so let's say proton. Who is the granddaddy of proton? Baryons. Barry is the granddaddy of proton. What do you see in the proton? Proton, you see up, down. 3 quark. The first quark is up, second quark is up, the third quark is down. Prove that. Up quark has a charge of 2/3. Up quark has a charge of 2/3, and down quark has a charge of -1/3. So if you do the math, 2 plus 2, 4, 4 minus 1 is 3. So 3e, 3 cancel, e, and e is how much? About 1.6 times 10 raised to negative 19 coulomb. Now neutron, who is the granddaddy of neutron? Of course me, Barry. Okay, neutron. Up, neutron also made of 3 quark. Up, down, down. Up is 2/3. Down is 1/3. 1/3. So let's do the math. 2 minus 2 is 0. 2 minus 2. You knew it all along that neutron has 0 charge, and there you go.